Welcome to the Second Nature webinar on En-ROADS, a free climate solutions tool. My name is Mia Sen, and I'm a climate programs associate here at Second Nature and the moderator and facilitator for today's webinar. And before I start introducing our speakers today, I wanted to take care of a few housekeeping items. First, just so you're aware, this webinar is being recorded. After the webinar, a link will be sent to you via email, and you will be able to use this webinar again, watch it, share it with your colleagues whenever you need to use the tool. You can have this handy with you. During the webinar, all the attendees will be muted. However, you will have the opportunity to ask questions, and there will be a portion which is a little more interactive. So feel free to unmute yourself and have a conversation. We will encourage that. And towards the end, questions will be collected and curated and asked of our panelists during the question and answer session at the end of the webinar. And as you like, you can use the chat window. And if you're experiencing any technical difficulties during the call, I will be there, and my colleague Shayna will also be there. So you can directly message either of us if you need to troubleshoot any issues. And now I will be introducing our panelists. We have Andrea Frank and Lisa Mitten. So I'm just going to give them a chance to introduce themselves before they begin.
Yeah, thank you, Mia, so much for having us. And it's a pleasure to be spending this hour with you. My name is Andrea Frank. I'm an associate professor in art and photography at SUNY Paltz, and I'm also a Climate Interactive ambassador. Lisa.
Lisa, you're muted.
Hi, thank you. My name is Lisa Mitten. I'm the campus sustainability coordinator at SUNY Paltz, where my activities span all dimensions of a higher education institution. I've been here 8 years, and I'm really pleased to be here with you all today.
Yeah, so again, thanks for having us. We have a climate emergency at hand, as we, I think, all feel very much, and one which is coupled with a social justice emergency, a biodiversity loss emergency, and currently also our public health crisis with COVID. So to tackle our steadily rising CO2 emissions, which are really like a core factor in all of this, in my mind, many pathways are being discussed today, and it's often unclear which strategies can actually lead us to toward a drawdown of atmospheric CO2, which is really our goal.
So what we hope you'll get out of today is really to figure out how this free online web-based En-ROADS tool can help enhance climate solutions literacy on your campus, in your organization, among students, faculty, staff, employees all across the spectrum of the different constituencies on a college campus, and also to think about how these solutions interact with each other and have different and differing impacts on different dimensions of the climate crisis. So what we're going to be doing today is just talking a little bit about climate with some introductory slides to kind of set the stage. And then we will be working the bulk of our time with the En-ROADS simulator. And then we're going to be discussing briefly some of the ways we have, and then some ways you could use the simulator at your institution in your own context. And then that will last until about 2:40, and then we'll have 20 minutes for a debrief discussion and Q&A.
Okay.
So if you could share in the chat, we'd like to learn a bit about those of you in the audience. If you could share your name, your institution or organization, and what role you play at your institution, so we can have a sense of who's with us here today. I also want to give out a shout out to all those New York colleagues in the audience. There's a lot of familiar names here.
Yeah, while you hopefully enter your information in the chat, I like to give a super brief introduction to En-ROADS. It's an accessible and scientifically rigorous tool that can help us understand how we can achieve our transition and climate goals through changes in energy use, specifically in consumption and policies. It is a global model that's important for us to know as we work with it. which has been carefully grounded in the best available science and has been calibrated against a wide range of existing integrated assessment, climate and energy models. It's been run for the US Congress, the US Climate Action Network, the UN Secretary General's Office, and many, many, many other places worldwide. So let's keep in mind that we are working with a system that has a carrying capacity limit. It's a finite system. It's intricately balanced and complex. It's Mother Earth, the only home that we and our ancestors have ever known. And I think that's why we're all here. We realize what a formidable challenge we're up against. Makes me feel this right away. I see amazing names and functions and key positions at different universities and places that you hold in different campuses and institutions, and the chat coming in. That's really, really exciting. So I'll now follow in my presentation. It's a bit of a hybrid presentation in that I want to really give you a tool and hand it over to you as something that we would love for you to use. So we're not going to do a regular climate action workshop, but we are going to use that format. So I'm going to go back and forth there, and you may choose to do it one day yourself with colleagues, for whole groups. I'll walk you through some slides and then work with a simulator, and then we'll show you more options how this might be helpful for you. Okay, so let's dig in. Our goal is simple. We need to figure out a plan and combination of climate solutions that will limit warming to 1.5 to 2 degrees globally, which is what scientists say might keep us in a somewhat safe zone. As you know, today we're at about 1 degree of warming and are already experiencing most disturbing and massive impacts. So this graph of temperature change over this century is what you're going to see in the En-ROADS simulator. The black line here, I'm going to be looking left and right because I'm working on 2 screens. I hope that's not too confusing here, but it's basically the black line, our business as usual projections between 2000 and 2100. We'll be mainly looking at that century. And it means if we just keep going with the actions and commitments we have made so far, if we continue with this business as usual, we will be ending up at 3.6 degrees Celsius, 6.5 degrees Fahrenheit by the end of the century. These horizontal dotted lines indicate our climate goal of limiting global warming to below 2 degrees, or ideally 1.5 degrees Celsius, which is at this point probably the best possible outcome. We're not able to actually stay at a lower point because we are working with a model with delays that are inherent, or with a system, not a model, actually, the Earth. At a typical workshop, we would go through quite a few slides now, and we have only a selection and are not going to go in depth because we understand you are deeply familiar with these concepts. We usually introduce the Keeling curve and other graphs. Let's just note here that we are in a steady increase, and we are at about 419 parts per million now of atmospheric carbon dioxide emissions. Here, a historical carbon dioxide record of about 800,000 years, which doesn't surpass 300 parts per million until 1950. CO2 concentrations are expected to continuously rise now beyond our 419 if we don't take immediate action. What we are seeing is truly unprecedented. Here we have a chart of the different greenhouse gas emissions and contributors over time, which we will work with using En-ROADS. In orange down here, we have the contributions, and red, you can see the carbon dioxide contributions from fossil fuels down here, and land use in red. In light blue then is methane, CH4, and nitrous oxide in N2O, and the F gases right up here. Industrial agriculture is responsible for 50% of methane emissions and 60% of global nitrous oxide emissions. Heavy industry and manufacturing, as well as consumer goods, are sources of N2O and F gases. Okay, so we have CO2 plus other gases that we will be dealing with and struggling with during this workshop and our future time on our campuses. We're looking at numbers and graphs in this workshop and often in our working life. But we're also part of a conscious, wildly diverse and complex ecosystem. And so I'm going to ask you, if you're up for it, to take a minute to just arrive in our bodies and on this earth, on this planet that we're actually doing this for. Let's ground ourselves, feel our seat, our sits bones, feel our feet grounded, throw our feet down into the earth. Find our breath and really breathe through this body that is so intricately connected with CO2 and oxygen and all that is part of this life on earth. And see that we just ground down into the different layers of this earth. And if we can just take a few breaths like that, arriving here with each other, being here as humans on this planet. Thank you. I appreciate it. Okay. Did I have this slide? Did I not have this slide up? I think I did. Good. Okay. So here is our basic En-ROADS interface. I want to introduce it before we start really working with it. There are 18 levers which we can manipulate in the categories of energy supply, transport, buildings and industry here, growth, land and industry emissions, and carbon removal. And we are showing right now, and there are other ways of things that we can show, the global sources of primary energy with coal and brown, oil, gas, renewables in green, bioenergy, nuclear, and new zero energies. And here on the right now, we have our temperature chart that we had shown earlier. Okay, let's continue. Yeah, so this is our first question that we would love to have you answer for us in the chat. What are your or your institution already doing? What are you or your institution already doing to reduce global warming? What are you or your institution already doing to reduce global warming? We'll test what would happen if your actions were to be adopted globally. Okay. So if you could start putting some into the chat, I'm sure your institution is doing something. You don't have to, you can also raise your hand and speak if you like, but I'm just putting it into the chat. All of that is good. We would like to collect a few answers. Biking, walking to work, I see. But Lisa, you'll be monitoring the chat, right? I'm going to be now working with it with En-ROADS. I'm going to switch over. Here we go, the live model.
So we have a couple thoughts in the chat, a bunch of different activities that different campuses are starting. So Andrea, why don't you, I know one of the big things that's happening across campuses is electrification through vehicles and starting, electrification of the transport system. So installing EV charging stations. So do you want to go model what happens when we electrify vehicles?
Yes, and just to tell you in terms of how we are going to be working now, I'm going to maybe do these first few sliders in depth with you, like you would do it if you were working with students or with a larger group, in order to encourage the most dynamic interactions. And then because we have somewhat limited time, I'm going to just show, like move the sliders and talk. So let's see. We're talking about transport electrification. We can always here look at what that means. That means purchases of electric cars, trucks, buses, and trains, maybe even ships, airplanes, using electric motors to help reduce greenhouse gas emissions. Okay, so we are increasing electrification. What if everybody did that? I'm not going to move this yet, I would love to ask the audience now to see, what do you think? And there are thousands of calculations going on in the background. What do you think in your head? What do you believe this, if this action was applied globally, would change global warming by the end of the century? Would we be at 3.4 degrees? Would we be at 3 degrees? At 2.5 degrees with this one action? If you could just put really quick some numbers in the chat, where do you think can we bend our temperature curve in order to, and if we really electrify transportation? 3.3, 2.6, 3.1. Thank you. I'm going to do this in the interest of time. We are going to be highly incentivizing electrification. Going to go back. Status quo, highly incentivized. We've changed the needle to 3.5, 3.6, depending on how far I go. This is interesting. This might be really discouraging for some, right? Let's see what happens. I would love for you to look at the red line. This is oil. If we incentivize electrification, our red line is coming down mid-century, and it's staying consistent at that point. Why? Because we are moving away some from fossil fuels. We are going to electric power. But what's happening? Look at the brown line here now. That is coal. As the red line is bending down some, the brown line is bending up, because our electricity is not only powered by renewable energy, but also by coal, which is the most carbon intensive fuel source that we have. So that's exactly, it depends on where the electric power is generated, somebody is typing. So yeah, we didn't make a big change yet. What else do we have? Let's see. What could we do now in order to help this problem?
So another number of folks have referenced renewable energy procurement, increased renewables. Yeah,
very good. So
adding solar panels.
Thank you. That is exactly that slider here in the energy supply area, where we could say, okay, if we are now having most energy, most cars powered electric, we need to get more electric, encourage or subsidize renewable energy more. Let's see what happens. I'm going to go back. Sorry, it's a little sticky here. I'm going to go from status quo to subsidized. Note that we went from 3.6 to 3.4 degrees. We moved the needle by 0.2 degrees, and we can see here that we have lowered our emissions. And let's see what happens with our green line. I'm going to go back, status quo to up here. Our green line shot up. Let's look at the brown line, before, after. Interesting, it bent back down. It came back down because we're not going to be relying on coal as much, because we incentivize renewables. Something that I think we just want to mention in this work here is that there is, of course, an environmental justice and social justice component that needs to be always thought with these movements. If we are subsidizing renewables, do communities that have been relying on coal have access to this? Is the money moving in the right direction as we are subsidizing a certain power source? Okay, what else, Lisa? What else could we do here?
A number of people have spoken about building energy efficiency projects, which I know is a very common low-hanging fruit across higher ed.
Yeah, energy efficiency means like either retrofitting old buildings with insulation, other heat pumps, etc., or building LEED certified buildings, etc. Just making our buildings and more energy efficient. Let's see what happens. I'm going to ask you, give me how much, where do you think we're going to end up if we make globally make our buildings and industry more energy efficient? Are we going to be at 3 degrees, 2.5, 2 degrees? A few notes in the chat would be amazing. What if we worked on energy efficiency for buildings and industry globally? Yep, I got a few, thank you. I'm going to move this up here. Let's see. I'm going to move energy efficiency to highly increased. Okay, I'm going back, status quo. We are at 3.2 degrees. We went 0.2 degrees down if we are highly increasing our energy efficiency. Now let's look at all the left sliders and observe what happens. This is all our energy sources. I'm going to pull this up. As probably would be expected, all of these graphs are coming down some. They are coming down some because we just don't need as much of, oil if there was a oil heat installed, or gas, or renewable energy, because if we don't waste as much energy by not having our buildings insulated, etc., we don't need as much. This is efficiency will always be a high leverage point. Even if we're still only at 3.2 degrees, it is a real big part of what we need to do. All right. What else? Oh, Lisa, we don't.
Muted. Okay, I'm here. We actually have a member of the Citizens Climate Lobby here, so I was wondering if it would make sense to model the carbon price. And I know a number of institutions are considering internal carbon pricing in absence of enacted policy.
Yeah. So yes, we could. So this is a little bit beyond maybe what has been done. We're kind of going to a next step, or looking at what carbon price could do in this scenario here. Okay. So again, I just want to show you that always you can come here. I'm telling you as somebody who I expect to maybe play with this tool later, you can really put in numbers here for what the carbon price should be and what that might mean, when it should start, etc. And then here, always you find an extra information button, which I think is really quite amazing. There's deep information in here that gives you examples of what that could mean. Grassroots campaigns generating public support for carbon pricing, countries and regions implementing carbon taxes. The big message, the key dynamics will be described, potential co-benefits of a carbon price. For sure, renewable energy becomes relatively cheaper, improves air quality, healthcare savings, etc. The co-benefits, right? The multi-solving aspects of this will always be described here, and equity considerations will also be here, so that we understand in a more dynamic way what's happening. Okay, sorry for the digression. Let's model it. What do we think? In your head, you don't have to type it in your head. What do you think a moderate carbon price will do? Just to think what's happening. I'm going to move this up. I'm going to go to a even high carbon price. Okay, we're at 2.8 degrees from status quo to 2.8, a high carbon price. Let's see, observe the brown slider here, the brown area here, which is coal. Coal is the most carbon intensive of our energy sources. So it is the one that is most affected by the carbon price, and it actually goes down the most. If you look at the oil slider, not doing as much, and renewable energy clearly is coming up some, as other cheap power sources like coal are getting cheaper. Our renewables are getting more expensive, are getting cheaper, right? And of course, there's opportunities for shifting now the funds from this carbon price to places that need support in this switch. All right, Lisa.
Andrea, we have
a bathtub model.
We have one question.
Yeah.
Is the carbon price modeled after a global carbon price, or is this localized to North America?
Yeah, that's a good question. Always, this model is a global model. So you could think about averages. It is the global number. It's really a way for us to start thinking about what we all would have to do, or what we are doing, what would happen if that was implemented globally. It's not North America specific.
Great. Andrea, yes, I think now would be a great time to move to the bathtub model as a conceptual framework for thinking about emissions.
Yeah, I think we all feel like we have been working so hard on our own institutions and our own lives to make changes and to reduce our impact or contributions to CO2. And this is from system dynamics professor John Sturman. He did a lot of studies that we seem to have a really hard time with the bathtub model. And some of you might be super familiar with it, but I just want to go over it because it really feeds beautifully back in here in thinking about our atmospheric CO2. So we have carbon dioxide in the atmosphere. Right now, it's steadily rising, 419, etc. We are on an upward trend. There's a lot of emissions coming in. The spigot is wide open, and what's coming out is relatively constant, and it's what the trees are absorbing mostly. Now, how can we even just halt the increase, right? What is necessary to halt the increase of carbon dioxide in the atmosphere of the water? We have to actually turn down the spigot very, very much, and so much so that there's only as much going in as flowing out, which is really not that much in comparison. This is a huge task, and for many of us, it hasn't been so clear that we have a massive task at hand, even just going to 419, to keep 419 steady. And then what do we have to do in order to slowly draw down? We need to turn the spigot closed even more. And of course, plant more trees, do some carbon capture, et cetera, as well, in order to help get more out, right? And this is right now only CO2, not all the greenhouse gas emitters. That's just on a little bit of a side note.
Andrea, do you want to show us a couple of the other graphs that can be?
I would love to.
Oh, you know, one of the graphs, we have someone from the Center for Biological Diversity who might be interested in seeing some of the biological impacts.
Yeah. So what's beautiful about this model, just first, really quick for all of you to get excited about exploring this, there is this little tab here to see a lot of different graphs at the same time for the solutions that we have right now modeled. You can see, whoa, cost of energy, if we did what we just modeled, would go up dramatically for a while, then come down again from the business as usual model, right? CO2 emissions would go down, come up a little bit. Temperature would slowly come down. We would be just about quite here. Greenhouse gas emissions and removals would look just about like this. Sea level rise, well, that's a very slowly responding model. We're still going to be seeing massive impacts, right? So, and you could click on these and make them your bigger graphs as well. Okay, let's look at this. There are some really interesting, there's the financial impact somebody might be super interested in. There are the impacts on the biological level. Sea level rise, let's take a look at it, what we just looked at, right? Right now, we're looking at 1 meter for sure of sea level rise. Let's look at species losing more than 50% of climatic range. This is a new slider that has just been added. They're adding, Climate Interactive is adding more and more of these sliders. If with business as usual, we are losing more than half of our, like species losing more than 50% of climatic range, this many of them are. So it's really staggering how much we are putting pressure on species to live with fewer and fewer, less and less range of habitat, basically. Decrease in crop yield from temperature, you can see is quite substantial. Lisa, what do you think would be helpful in terms of our audience? You're a bit more.
I mean, in terms of graphs.
Ice-free Arctic summer. Pretty scary graphs here. Probability of ice-free Arctic summers in 2050 is 100% at 2100 with the scenarios that we're looking at, for example, right? So,
Andrea, I'm wondering if we have about 6 minutes left till Q&A time and debriefing.
Yeah.
Oh, we could do two things. We could go to the final slides, like how you can use this in your institution, or we could do that and how do we get to 2.0 or 1.5? What's one scenario?
Yeah, let's look at that for sure. I think one thing that seems really, really, really important is to understand that we're dealing with CO2. Land use CO2 is in green here, and in gray we have the energy CO2, carbon dioxide, but then we also have these other gases that are coming from industry, from agriculture, etc. And if we want to actually reach our goals, we have to address those. That means these sliders here in land and industry emissions are really important. Just from a biological perspective, of course, pulling down deforestation as much as we can, which I don't think is getting easier with the fires that we're facing. You can see what's happening with the green line here. Can you see that? The green line, land use CO2 is coming down as we halt deforestation. And if we then increase afforestation, we are actually bringing that down a little bit. Now, planting trees is slow, so we don't see so much by the end of the century, but it's a very important aspect. And then we got to look at methane and other gases, and these need to be reduced, and that can be from agriculture and fertilizers, etc., but also from industry. So if we highly reduce our methane and other emissions, we're getting to a better outlook in how we might be able to stay kind of below tipping points, right? And then we got to do our energy efficiency, of course, also in the transportation sector, meaning public transportation, meaning biking, walking, hybrid vehicles, better efficiency for our vehicles, etc. And you see how a lot of graphs are moving at the same time. Building industry electrification, also important. What you will find is that if I move sliders right now and you're observing the graphs, it might not be so visible what's happening because we already did so many other things. We already had a carbon price, etc. If you started with this one action like electrification, let me just do that real quick. Electrification, building and, for example, transport efficiency. See, I'm going from 3.6 to 3.4. Because in our other model that we've been working on, I went back here, because we did so many other things already, that's not showing to do so much, but it is part of a climate solution that makes sense. And then if we really want to reach our goals, we might even have to go to carbon removal. We might have to get an even higher carbon price, or, you know, we can tax other, in addition, different sources as well in order to get to our solutions. But you can see that it's all possible. But right now I'm moving sliders without understanding the complexity of what we're doing. This is a massive challenge. I'd be curious if anybody wanted to learn about a specific slider, if you wanted to put that, or a specific area that you might be working in, you could put that in the chat as well, and we could see and talk about that maybe specifically a little bit.
Andrea, I think we should move to how we can.
Oh, we gotta move on. Yeah, we can do more in Q&A, and
we can talk about that in Q&A.
Yeah. Super. Okay, thank you, Lisa, for keeping us on track. Always the more important job, even if not very fun. So how can you use En-ROADS? We hope that that you got curious enough to want to dig in and learn more here. So we want to go from the easiest way of working with this to a little bit more complex or more time investment versions. So without being deeply familiar with the tool yourself, you can assign an En-ROADS student assignment that you can find online on climateinteractive.org. There's a short video that introduces the simulator. Students will play with it themselves. This could be also part of an initial training for eco-rep programs that you have in your university. There's about 5-page assignment, has step-by-step instructions, and students submit their answers together with a screenshot of the model result they came up with and a summary of their decisions and reasoning, right? The cool thing is that if people really believe nuclear energy is what needs to happen, they can model that and build around that, for example, which is the example they have here online, which I grabbed from the website. You can explore the tool with your colleagues or on your own and understand the effects of possible technologies and policies that you're thinking about, because you understand more about the interrelations or what it does. And you can also host an En-ROADS climate workshop on your own or with a facilitator. There are facilitators available on the Climate Interactive website. I'm sometimes available. People are, volunteering to do this if you don't feel comfortable. It's designed really to run by anyone dedicated enough to learn the facilitation. You don't have to be a scientist to do that, and can be run in person or online. It's free, completely free. There are sponsors that made this a completely free tool. And you can host an En-ROADS climate action simulation. It's a highly interactive role-playing game. Now, Lisa and I have run several iterations of the similar C-ROADS climate action simulation game at SUNY Paltz before COVID pushed everything online with really great success and fun. It's conducted as a simulated emergency climate summit organized by the United Nations. And you actually really play Secretary General, etc. And it's very formal and fun. And there's a lot of negotiations happening, which is a great learning tool, really. So if you want to dive in really deeply into this tool, you can become an En-ROADS climate ambassador like I am by going through a series of free and very accessible online workshops offered by Climate Interactive. And then you become part of that community where there's updated workshops, the latest news. It's really a very lively and wonderful group. And all this material is free and readily available at climateinteractive.org. It's really nice. There's no catch. There's nothing. This is done because it's so necessary that we have these tools at hand. Yeah, thank you. I think this is what I had here to hand over. And Lisa, if you want to.
Yeah, so we have some questions for you, but you're also welcome to ask us questions. Mia is going to be facilitating that. But our questions for you, in case you want to go in this direction, are what surprised you? What were your key insights? And how do you want to use this tool, or how are you interested in learning more about using it in your community?
So for folks who want to answer those questions, feel free to type it in through the chat or raise your hands, and I will call on you and you can speak as you desire.
I'm just seeing a lot of carbon removal slider requests there. So I'm just opening this up so you can read what they say here. Should I read it for everybody? Might that be a good way? Pull carbon dioxide out of the air with new technologies that enhance natural removals or manually sequester and store carbon. CDR technologies include direct air capture, bioenergy, carbon capture with carbon capture and storage, biochar and others, but not including coal or gas CCS. CDR is not yet used widely, and most approaches face significant barriers to deployment. It's still, there is great potential, but most of these technologies are still undergoing pilot testing. Right.
Thank you, Andrea. There are a few other questions that are coming in, a few about the technical aspects. For example, Kelly Dunnings is asking, can you download any of the data?
Yes, I mean, like there's a lot of information on the Climate Interactive website also. And just so you know, there are assumptions here, for example, the climate system sensitivity, all here. I just want to find, like, often when you go into sliders, you will find a lot of references also. And there are ways of exporting some data as well. There's share use. I'm not, oopsie, I'm not going to go. Here is our user guide. There we go. That has a lot of information, content, and like material that dives deeply into different areas. So it's available online. Let's put it that way.
Thank you. Another question that came in was that are the costs of policies factored in the calculations other than carbon pricing?
The costs of policies. I'm not sure that I understand the question. Elisa, do you understand?
I am not sure.
Michael, would you explain?
I imagine this has to do with energy supply.
The cost of policies. I mean, what? Can
you hear me?
Yes.
Yeah.
Yeah, so if you increase renewables, there's going to be a cost for that associated with the equipment, the installation, the labor, and all that. That applies to all these sliders. So there's a budget, universities have budgets. We can't do everything. And so we have to, are there any cost estimates of all these different policy strategies that help us determine what the total cost of the university is?
So there are, what I can say is that it's really, really complex how all these aspects have been calculated and put in relation to each other. I just pulled up the cost of energy slider just because, and there are many other cost factors. We can always ask these questions specifically to Climate Interactive, because the tool builders are continuously doing that and are interested in this dialogue. I know that cost is in some way pulled in there, but for example, if we are saying, okay, we're only subsidizing renewables, but we're not bringing in, taxing carbon, then yes, where does the money come from? It's all hypothetical at this point. It's not clear where it comes from. It needs to be figured out. Is that helping at all?
Yeah, I guess
Yes.
I just want to add that, like, I don't, this model is not going to help you figure out how much it's going to cost to implement all of these strategies on your campus or like within your state. I think that one of the main powers of this model is just to have a wow moment with students, with faculty who may not be super familiar with climate solutions, with managers, with upper administration, that the diversity and scale and time sensitivity of implementing these solutions is so critical. And they're very broad, and we need to do everything. Now, this does not help us with the cost question, especially those of us working in operations.
Okay, that's fine. I mean, it's conceptual. I get that.
Yeah.
And I didn't mean to say it pertains to universities, because this is a global scale. So it's not relative to the scale of a university, although it would be nice if one could make it so. But there's no cost relevancy. No, that was my question. You were answered it, so.
Thank you, Michael.
Can I follow Michael's question on that? Because again, I think as some, for we there and the sustainability directors, when we're trying to pitch ideas at our institutions, as much as we like it or don't like it, the CFOs and the administration and the board, that's usually their first question is, how much is this going to cost and who's paying for it? So, I mean, I think Michael's question is really relevant, and that is the real space we're in, whether we like it or not, particularly with COVID, where money's even tighter than normal, that I can't always win the moral, ethical, like this is the right thing to do. Let me show you scientifically why this is the right thing to do. Usually a lot of those decisions are being driven by how much will this cost? What's the payback? What's the ROI? And so I think that's an interesting, that's Michael, you hit the nail on the head in terms of, I think that's one of the things at a campus level that may be a limitation to the tool, depending on what we're using it for beyond the education piece.
Yeah, we've primarily used it for a student and academic faculty audience. And we also have a major carbon neutrality effort that is beginning in a more significant, sustained way. And I was thinking about using this tool as an introductory overview for all those diverse stakeholders who are ultimately involved with that process, as a just conceptualization framework about what the solutions are, and for people to start thinking about how they fit in, and also about the urgency.
I'd like to add to that. This is Ann Doherty from Ropey. I'm a manufacturer who used to work in education. And this tool, to me, would show our managers what the relative impacts of different possibilities are. They can figure out the dollars and cents themselves. They're geniuses at that, right? What they don't know, they don't want to do something that won't make a difference, though, that really won't make a difference. They're concerned about our businesses. They're concerned about rising water and climate risk. And so I think this is fantastic for the managerial C-suite. It's a couple steps away from actually putting a renewable project in place, but I think this totally gets the conversation going. It's fantastic. Thank you.
Thank you, Anne.
It's nice in a sense that it's not biased, that it's just running the numbers in a way, right? So if somebody thinks something should go this way, well, let's check it out. What does nuclear do, right? Or what's happening here or there? You can look at it and get a sense of the impacts or non-impacts of certain aspects. And I think that the main takeaway to me always is the incredible urgency to do everything at the same time, because there is no one main thing to do. We need to do all these things and more in order to get anywhere close to livable, really, right? Manageable for future generations.
Yeah, thanks, Andrea. I was wondering if there are any other follow-up questions or anything specific to the tool usage or how it was created. I see one from Melissa coming in, which, have you used this tool in Second Nature to get percentage target and emission reductions? We actually recently got introduced to the tool, and we've been sharing it with a few of the folks in our within our networks, mostly just because it's a free tool and it's really easy to use, and it's very, very exciting to actually see, with graphs and numbers what's happening. So we have been sharing it out, yes.
Andrea, I noticed you didn't, I'm curious, the toggles, no, you didn't do anything in the growth sector. To me, it seems like the economic growth and population could be major drivers. What happens when you toggle those?
Yeah, I'll show you. Now, what we can do is we can start a new model or build on top of what we have already. Let's build on top of what we have. I could also go to a fresh one to see it more clearly. Let's see. Yes, population is a big factor always. Let's see. Not growth. We want a low growth, right? We want to pull down population. Now, there's not much that we can see happening. Let me just. I'm going to go back to our usual graph so we are more familiar with what's happening. It is not showing much that has to do with the fact that we're only looking at these 100 years, right? So fewer people don't over this time span it happens slowly, right? A decrease in population. Economic growth, if we pull that down, that will do something, right? If we have a lower growth, clearly we're getting to 1.7 with low growth. It's just less production, less of everything will again be less energy demand, etc. But they are not those silver bullets, as they call them, either, right? I mean, they are. There's carrying capacities for the Earth, etc. But if we're looking at the numbers right now for this time span, this is what we get.
Andrea, could you show population growth and economic growth out in a fresh model that everything is?
So this here, I'm gonna reset this. Reset. This is just how you open. By the way, if you go to Climate Interactive, somebody was asking. I'm just gonna go do that real quick. Climate Interactive. Oopsie. You come here. You click here. You get to the simulator. Here's the simulator. You're right here. Okay, this is your simulator. This is what you get, and you can play with it right away. Everybody can. There's no sign up or anything. Let's see, population, decreased population. We definitely see an effect here. Economic growth, decreased economic growth, pretty good, right? If we look at the small graphs, we can see all kinds of, everything is getting a little bit less stressed here, right? With less of all of that. It's definitely these are important aspects, clearly, yes. But they're not the only thing we have to do by all means. Okay.
Thank you. Are there any other questions regarding the tool, the usage, or if there's anything else you'd like to see Andrea manipulate?
Andrea, I had a question. I mean, given that how hard it is, does it ever backfire where someone says, that's so unrealistic, we'll never do all those things? Like it almost works against it to show that we have to hit pretty much every slider to make us get there, that they're like, you know, that they almost get a bit of pushback, like why we can't do it.
A good question. We usually have, and I think that's really, really important to, like, Climate Interactive has, like, there's the intro slides, there's the working with the simulator, and then there's a debrief. How are you feeling? How, you know, like, there's a lot of feelings coming up. But what I've found is more of a resolve to say, yeah, gotta do my part right now, and we can do this. Because some go like, well, it's, you know, the big business is not doing what they should. I might as well just keep doing what I'm doing. There is a resolve to say, no, this is the time we can do it. So I've found it sobering for people, but positive. Yeah.
Thanks. There's another question in the chat, which asks about if food has been accounted for in terms of food waste or even consumption, or if that's accounted for in like the energy supply separate within the energy supply itself.
Yeah, I think that's a good question. There's food waste, like what we have is like, what if most everyone worldwide was going vegetarian, right? Which is often something people do for the climate. And it is, and actually, because it came up so often, Climate Interactive gave us a model of how to deal with that. There is, like, in agriculture and waste right here, take down 20%. Oopsie, I can't open it here. I can go 20% more. So I can do till 83 or something. I can, and then if I don't, because we're having less cows with all the methane emissions that come with it, right? We also need less transportation energy efficiency because we don't have cooled, or just in general moving meat back and forth and cooling, etc. 0.5%. So we can bring energy efficiency of transport up because we are using less. And then deforestation will also be reduced because we need less areas, fewer areas for the cattle to graze. So there is, if it was in a fresh model, there is an impact, maybe 0.1, 0.2 degrees from going vegetarian worldwide, with, of course, is not feasible for everybody, because there are some countries or places where you can only have your goats and there is nothing much growing that is directly consumable, and it's a cultural issue. But yes, we can and should be doing that.
So it looks like we're just about up on time with a couple of minutes left. So are there any final burning questions? Or Stacy is asking food waste pertaining to food decomposing in landfills, if there is a model for that.
Like we have, I opened here in methane and others, it's all put in one slider. But if we went here, we could go to agricultural and waste emissions, and put that in. If I went to individual sections of sliders, I could make it very, very specific and look at agricultural waste and waste and agricultural and waste emissions if I wanted to. I can't do it right now because I use the other slider, like the slider in the main tool. And then there's energy and industry that you could do separately, and then you could see when you want to start pulling those down, etc. Right? So yeah.
Great. Thank you, Andrea. I was wondering if we could go back to the presentation so I could just share a little bit of information with everybody before we say goodbye. Thank you for all your questions and answers. Thank you to our speakers for this wonderful presentation and answering all our questions and introducing us to this very exciting tool, and to all our attendees for taking the time today to come and watch us share this lovely tool with you. Just as a reminder, again, a recording of the webinar will be posted online tomorrow, and you will also receive a link to it in a follow-up email. And if you have any additional questions, please feel free to reach out to me and I can connect you with either Lisa or Andrea or answer it myself. Thank you so much. And we really do look forward to seeing you next time.